All right, part 2 of lesson 13. All right, so continuing our discussion on decimals, now we are going to insert these symbols that they come up a lot in this class, I know. We're going to insert less than, greater than, or equals to make true. Okay, so yeah, you'll notice we do this a lot in many of our lessons, but this is the next thing that you're going to see in the homework in lesson 13 on my math lab. So we're going to insert less than, greater than, or equals to make the following statements true. So example number 1, you'll see something like this: 0.215 with a blank, and then 43 over 200. All right, so we've seen examples where we've had to compare numbers, integers with negatives, and then even in our last lesson, I believe it was lesson 12, we had to compare two decimals, and I think we've even compared fractions before, but we have never compared a decimal and a fraction. And you're gonna see a few of these in your homework and even on quiz number 6. So you're gonna have to know how to compare a decimal with a fraction to know which one's bigger or are they the same. So for all of these, here's my advice to you guys. I would make sure that I rewrite the problem so that everything is in the same form. And it's usually a little bit easier to make everything into a decimal. So we want to make everything into a decimal. So if I'm going to rewrite this, I'm going to just bring the 0.215 down, okay, because that's already a decimal. But my 43 over 200, I'm just going to take my calculator and do 43 divided by 200. And when I do that, it gives me a decimal there, 0.215. All right, 0.215. And so I'm going to change this to a 0.215. And now you ask yourself the question, which one is larger or are they the same? And you can see very clearly 0.215, 0.215, they are the same. So that means you want to go back up to the original problem and put in the proper symbol. So they are equal. All right, example number 2. Example number 2, what about something like this? This gets a little tougher. 0.1 with a bar over it compared to 2/17. All right, so 0.1 with a bar over it compared to 2/17. All right, so in this one, what I would do first actually is I would do the 2/17. I would convert that to a decimal. 2 divided by 17. And when you do that, you get this large number right here. You get 0.11764705, blah, blah, blah. It keeps going, right? Okay, so I'm gonna write that right under it as 0.117647. I know it keeps going, but I don't really need like every single decimal, so I'll chop it off right there. And then for this one, even though this one's already a decimal, it's a repeating decimal. So you probably want to go ahead and write several digits so that you can compare the two. So 0.1 repeating just means 0.111111, and that's probably enough. You probably want to make it so that the two numbers have an equal number of digits. Here I wrote 6 digits, here I wrote 6 digits. And that'll just help you to make sure that your answer is real accurate. And so now when you compare these two decimals, it's easy to see which one is larger, because if you notice right here, they both start off 0.1, and then the next number is also a 1. So far they appear equal. But then if you look at the next digit, there's a 1 there, there's a 7 there. So this is where it breaks down and they become different. So which number is larger, 1 or 7? Clearly a 7 is larger. So that means that the greater than symbol opens up to this decimal here with a 7, so that when you go back to your original question, you want to make sure you put the symbol in like that. Okay, so it's 0.1 repeating is less than the fraction 2/17. Final answer. Okay, so that's how you do that one. And let's just do one more of those. Negative 51/91. Okay, so negative 51 over 91 compared to negative 0.564 with the bar just over the 4. So this one is kind of really testing a lot of skills here. And so first of all, you'll notice both of these numbers are negative. That's going to make it a little bit difficult, because remember at the end when you ask yourself which one is bigger, it's like the opposite of what you think because they're negative numbers. But they are both negative. So let's go ahead and convert this negative 51 over 91 into a decimal. We know it's going to be negative, so I'm just going to go ahead and do 51 divided by 91, and then I'm gonna hit equals, and we get this number right here, 0.560439560. So I'm gonna go ahead and just write some of those digits, 0.560439556. I mean, I ended up writing most of them. All right, so there's that. And then I'm gonna go ahead and convert this one now. This one is negative 0.56. I guess technically I'm not converting it, but I am writing it out. It's already a decimal, but I wanna write it out so that there's more digits. So since just the 4 is repeating, I'm gonna go 4, 4, 4, 4, 4, 4. Make a bunch of 4s so that these are approximately the same number of digits so that you can compare them very easily. And so now you'll notice the 5 right after the decimal is a match. It's the same. The 6 also a match, but here's where it breaks down. You have a 0 versus a 4. A 0 versus a 4. So now again, since these are negative numbers, okay, negative numbers, which one is actually greater, a 0 or a 4? Well, a 0 is greater than a negative 4. So that means the symbol goes that way right there. And so for your final answer, you're just going to put it in like that. Negative 51 over 91 is greater than negative 0.564 with the 4 repeating. Okay, so just be very careful. That one was by far the trickiest. Now, the next thing that you're going to see in my math lab is this right here. It's going to say write in order from smallest to largest. And for those of you who have taken placement exams like the ALEX, you probably are familiar with the fact that placement exams absolutely, for whatever reason, love these problems. They love giving these problems to people. And it drives me kind of crazy because they're really kind of difficult to do by hand, especially. Even though you guys know how to do these by hand, I'm gonna totally say just use a calculator. It's way easier. Unless you're practicing for a placement exam, then go ahead and do these by hand. So that is up to you. But you're gonna write in order from smallest to largest. We're just gonna do one example because I think once we do one, we get it. And we've done so many problems like this before. So here's the number 7.56. And then I'm going to give you a fraction, 67 over 9, and then I'm going to give you one more decimal, 7.562. All right, so you have a decimal, a fraction, and a decimal. And the question is, write in order from smallest to largest. It's kind of hard to see what the correct order is just looking at the problem because you have 2 decimals and then you have a fraction. And comparing decimals and fractions are very hard. And so as we said a moment ago, like we did up here, what you want to do to start this problem is make everything in the same form. And it's usually the easiest to put everything in decimal form. Now also, keep in mind, you're going to put everything in decimal form, but make sure that every one of these numbers has the same number of decimals. Now, I'm going to go ahead and convert the 67/9 first because it's a fraction and I want to use my calculator. You could do it by hand, but I'm going to use my calculator just to make it easier and faster. 67 divided by 9. When I do that, I get, oh, there it is, 7.4. The 4 is repeating. So 7.44444 is forever, right? 7.444. Now you might be wondering, why did you choose 3 4s? Well, hopefully you're kind of seeing the reason why I did that on purpose. I chose 3 4s because if you look up here, this number, I don't have to do anything to it. I'm just going to bring him down. He had 3 decimal places, right? 1, 2, 3. So I want this one to also have 3, and that means I want this one to also have 3. This one only has 2, 7.56. So of course I'm going to need to add a 0 on the end of it to make sure that all of these are all decimals and all of them have the same number of decimal places. All super important. Okay, so now we have our numbers and we're going to go ahead and compare them. You'll notice all 3 of these start off 7 point. So yeah, so far they appear to be the same. Then we've got a 5, a 4, and a 5. Well, the directions said write in order from smallest first. So you can tell right now which one of these is the smallest. It's this one right here with the 4, because 4 is obviously less than these 2 5s. So that means this number right here is your smallest number. So I'm going to go ahead and set up my answer down here. so that I don't lose track of what I'm doing. I'm going to move this up a little bit. So answer. So I'm going to say 67 over 9, comma, right? Because that's my smallest one. I'm done with that one. Now I'm just comparing these two. So let's look at the next number after the 5. Well, the next number is a 6. So again, they're the same. So far, they're very much the same. So now you have a 0 versus a 2. So I would ask you which one is smaller, 0 or 2. Obviously, the 0 is smaller. So that means this number comes next. 7.56 and comma, oh, it's a bad looking comma. And then last, of course, the largest number is this one right here, 7.562. So my final answer is this right here in order from smallest to largest. Again, placement exams, I don't know what it is, but they love these questions. So if you want to do some extra practice on these in my math lab, feel free. You can, click buttons and give, have them give you more examples, or you could try doing this homework twice. Totally up to you. But yeah, just take your time on these and make sure you convert them all into decimals and compare them with the same number of digits. All right, there's only 2 more things that you have to know for this entire lesson 13. And so the next thing is solving equations with decimals. Now, I hope that does not scare you. I do not mean to make it sound like it's something new, because actually it's not anything new. It's just solving equations just like we've been doing. So I'm gonna go ahead and set up our first one. The directions will probably just say solve, okay, because you're solving equations. Here's example number 1. I'm going to give you x plus 1.2 equals 7.1. Now, we've done equations like this. We've done several just like this, but this is the first time I've put decimals in the problem. So again, having a calculator is going to be extremely handy for these problems. You can do them by hand, but it's a lot easier to just use the calculator. So I like to do my bridge thing. If you'll notice, this equation is only a 1-step equation. That's very cool. It won't take very long. In this equation, you want to ask yourself all those questions that we always ask ourselves. You want to say, is there any distributive property I can do? Are there any combining of like terms that I can take care of on either side of the equal sign? And the answer here is no, there's none of that. So then you ask yourself, do I have x's or variables on both sides of the equal sign? Again, the answer is no. I only have an x here. So we're already onto that third step that we wrote in our notes a while back now, where we want to get the variable by itself by undoing operations to things that are on the same side as x. In other words, we got to get rid of this plus 1.2. So the only way to get rid of a plus 1.2 is to minus 1.2, right? Or subtract 1.2. So it cancels there. So all you have left on the left side is just an x. And on the right side, you have 7.1 minus 1.2. You could use a calculator, or you could do it by hand. Maybe you could even do it in your head. I don't know. But feel free to use whatever means you want. The final answer is x equals 5.9. Okay? All right, example 2. We're going to do 6 examples with equations because it's kind of been a while since we've done these. And I just want to make sure you guys remember all the different types of equations that you could possibly see in your homework and on the quiz coming up. Okay, negative 5y equals 2.15. Now in this one, again, you want to ask yourself those same questions. Can I use the distributive property on either side of the equal sign? Can I combine like terms? The answer is no. Do I have any variables on both sides of the equal sign? No, I only have a y over here. There's no y over here. So again, we're onto that third step where we want to undo operations to get rid of numbers that are on the same side as our variable. So we have to get rid of this negative 5. You probably remember me saying this maybe 5 or 10 times because it's happened so many times. I have seen so many mistakes, but you guys have really, honestly, done so well. I don't even know if I saw anyone make this mistake on any of the quizzes or assignments on my math lab. But what I mean is I've seen so many students that say, oh, negative 5. They think, oh, the opposite of minus 5 is plus 5. So they go ahead and they add 5 to both sides and they get the wrong answer. Because remember, this isn't just minus 5. It's not y minus 5. It's negative 5 times y. This is multiplication. So the opposite of multiplication is division. So what you need to remember to do here is divide by -5 on both sides, right? Divide by -5, or you could write it as a fraction, however you want to do it. So then it cancels. So you end up getting y equals 2.15 divided by -5. And when you do that, your final answer is -0.43. Okay, 2.15 divided by -5 is -0.43. All right, example number 3. Okay, these are going to get a little tougher because, again, we're just reviewing all the different things we learned about solving equations. As you're watching this video, I very much encourage you guys to try to go faster than me when you're solving these equations. And I don't mean try, like I'm so impressively fast, but yeah, just try to go faster than me, because then that way you can kind of see what you know and what you don't know. Since we all know how to solve equations by now, see if you can go faster than me and then get to that final answer before I do, and then check yourself when I get to the answer. So here's example 3, 7x minus 9.64 equals 5x plus 2.32. All right, now in this one, it kind of looks like you could combine like terms, but you can't. You have an x here and no x here. And on this side, you have an x here and no x here. So there's no like terms on any one side of the equal sign. There's also no distributive property, but there is a little something happening here. You got an x here, you got an x here. This time we do have variables on each side of the equal sign. When that happens, you got to get those variables together. You probably remember me asking you this question in class when I saw you face to face. One of the last times I saw you guys, I asked you, you have two options here. What do you think is easier? Do you think it's easier to subtract 7x on both sides, or easier to subtract 5x on both sides? And neither method is more right than the other one, but there is one that's a little easier. And I always tell you guys, try to encourage you guys to subtract the smaller numbers so that you don't have to deal with negatives. So if I were you guys, I would subtract 5x on both sides, so it cancels over here. And now you get 7x minus 5x, so that's 2x minus 9.64 equals 2.32. Okay, so now this is what we get. All right, so we're getting there. We've got our x's all on one side of the equal sign, but we want to get rid of things that are not the variable on this side of the equation. And remember, I encourage you guys to try to get rid of the things that are furthest away first. The 2 is attached to the x, so don't get rid of that first. Get rid of this over here. We've got a minus 9.64, so the opposite of that is to add 9.64, right? We're going to add 9.64 to both sides. And so now we get 2x equals 2.32 plus 9.64. So that equals 11.96. And then once you get down to this step, you have only one last thing to do. Get rid of the 2. Since it's 2 times x, we're going to divide x on both sides. I'll just use it in fraction form, but you could also write divided by 2 if you like that better. Divided by 2 over here as well. The 2's will then cancel, and you are left with x equals 5.98. Okay, final answer, 5.98. And of course, you can always take these answers and check them by putting them back into the original problem. You guys probably remember that if you have time and if you feel like you need to, especially on exam number 3 coming up in a few weeks. You can feel free to check your answers. Okay. Again, we're doing 6 examples, so now we're on example 4. We're halfway through our examples here for equation solving. Example number 4. Here we go. How about this? 2 parenthesis x minus 1.3 parenthesis equals 5.8. Okay. All right, so then there's that. I'll make my bridge again, and here we go. Now, there is no combining like terms on each side. However, this is the first example I've given you in this lesson where we do have our friend, the distributive property. It's been a while. We haven't worked with the distributive property for a while, but remember, that just means you take whatever number is on the outside of your parentheses and you multiply it times each term inside. So 2 times x is 2x, and then 2 times, careful here, 2 times negative 1.3, right? 2 times negative 1.3 is negative 2.6, okay? And then I'm just going to bring down the equals 5.8. So now we're here. Okay, once you get to this point, we can't combine like terms on either side. We did the distributive property. We do not have x's on both sides of the equal sign. So that's cool. So now we are ready to just go ahead and start getting rid of numbers that are on the same side as our variable. So here's x. We need to get rid of the 2 and the negative 2.6. We want to start by getting rid of the thing furthest away. So we want to get rid of the minus 2.6 by adding 2.6. So plus 2.6 on both sides. So that leaves us with 2x equals, carry the 1, 8.4. 2x equals 8.4. And now divide by 2. Divide by 2 to get rid of that 2. And so x equals 4.2. Final answer, 4.2. Okay, great. Example 5. So let's keep it going here. Example 5. How about this one? 2.7x minus 25 equals 1.2x plus 5. Okay, so here's a problem that's actually pretty similar to example number 3 because there's no combining like terms that you can do on either side. There are no distributive properties to take care of. But we do have x's on both sides of the equal sign. Here I've got an x, here I've got an x. We do have x's. Okay, so we need to get them together. So the question is, do you want to subtract 2.7x or subtract 1.2x? Again, if I were you guys, I would always take the smaller one. So I would subtract 1.2x. So that cancels. And so over here, you're just left with a 0.5x. Oh, I'm sorry, 1.5x. 1.5x minus 25 equals 5. Okay, so that's what we get there. All right, so now again, we're down to kind of like that last step in our notes from a while back. We want to get rid of the 1.5. We want to get rid of the minus 25. You want to start with the thing furthest away. So we're going to get rid of the minus 25 by adding 25 to both sides, cancel. So now on the left side, all we have left is 1.5x equals, I'll make my bridge a little longer, equals 30. So you have 1.5x equals 30. And then your last step, of course, is to divide by a decimal. I think this is the first example we've had where we had to divide by a decimal. So that cancels. But if you're using your calculator, it really doesn't make any difference. 30 divided by 1.5 is 20. Okay, good. So your final answer is 20. X equals 20. Great. Okay, we are getting there, guys. We only have to do example 6 and then one more example of something different, and we are done. Okay, so let me line that up again. Yeah, okay. Example 6. Here we go. 4x plus 7.6 equals 2 parentheses 3x minus 3.2. Actually, let me make that kind of long. Okay, there we go. All right, this is a big equation. There's a lot happening here. All right, if you look at this, there's no combining like terms to do, so that's cool, but we do have distributive property. I'm gonna just bring down the left side. 4x plus 7.6 equals, here I'm gonna use my distributive property to do 2 times 3x, 6x, and then 2 times negative 3.2, so minus 6.4. So that turns into that once you do your distributive property. Okay, so we did the distributive property. There's no combining like terms. However, we do have x's on both sides of the equation, so you can either subtract 4x or subtract 6x. Since they're both positive, you can subtract either one. But again, I would take the smaller one any day so that I don't have any nasty negatives. Cancel. So what's left on the left side? We've got 7.6. And then on the right side, we've got 6x minus 4x, which is 2x. And then just bring down your minus 6.4. Okay, so we are super close. Now, our 2x is on the right side of the equation. That's okay. That does not matter. You can keep it there. You can keep working the problem. Remember, it doesn't matter which side your variable ends up on at the end. So here we want to get rid of the 2. We want to get rid of the minus 6.4. And so, of course, we want to get rid of the thing furthest away from the x first. So we're going to go ahead and add 6.4 to both sides. And so what we're left with over here is 14 equals 2x. Okay, that comes out to a nice 14. 7.6 plus 6.4 is 14. And then your last step, of course, is to divide by 2. So you end up with an X on the right side and a 7 on the left. Okay, great. So your final answer there is X equals 7. And so that concludes our equation solving. And so now, guys, I just have one last little thing I want to talk about with you. The very last question on your homework, also the very last question on your quiz, number 6, is about finding the mean of a bunch of numbers. Now, you might remember what mean means. Find the mean, it's spelled like this, right? M-E-A-N. Find the mean, it means the average. You might remember studying years ago mean, median, and mode. Okay, well, the good news is we really only need to discuss the mean in this class. And it just means you're finding the average of the following numbers. And it is totally okay if you forgot how to find the mean or the average. Most of my students every year kind of seem to forget something about it, but there's always a few students that remember how to do it, and so I wish I was with you guys and I could ask like who in here knows how to find the mean of a bunch of numbers. Let me give you our one example that we're going to do, because we really only need one example. Once we do one, I feel like you guys will be like, oh yeah, I remember this, and you get it and you can move on, and I think you're good. So here's the numbers I'm going to give you. 4.9, comma, 7.1, comma, 6.8, comma. I'm going to give you another 6.8, comma, 5.3, comma, and a 4.9. So these are just a bunch of data points, just some numbers that I'm giving you. Now, if I was asking you to find the mean, you would have to put these in order. I'm sorry, not mean, median. If I was asking you to find the median, you'd have to put these in order from smallest to largest. But the good news is, when it comes to mean, we don't care about order and smallest to largest. So what you want to do is this. I'm going to put this in parentheses next to the directions where it said find the average or find the mean of the following numbers. All you have to do is this: add up all the numbers. Okay, this hopefully sounds familiar. Add up all the numbers and divide by how many numbers there are. How many numbers there are. Okay, you're going to add up all the numbers and divide by how many numbers there are. So probably a lot of you are sitting there thinking, hey, I knew that. I totally got this already, and that's great. That's awesome. So what you're going to do on the calculator then, I would just use a calculator. Again, you can do them by hand. 4.9 plus 7.1 plus 6.8 plus 6.8 plus 5.3. Oops, didn't mean to put a comma in there. Plus 4.9. If you add all of these numbers up, you should get a 35.8. Okay, that's what you get when you add all these numbers up. You should get a 35.8 for the total. Now, it did say that you add up the numbers and then divide by how many numbers there are. How many total numbers did we have? 1, 2, 3, 4, 5, 6. So you're going to take that number, 35.8, divided by however many numbers there are. There are 6 numbers in this case, 35.8 divided by 6, and you get this, 5.96666, and it keeps going, which is the same thing as 5.96 with a bar just over the 6. Now, if in my math lab it does not tell you to round, you can leave your answer like this. Okay, you would just write 5.9 with the bar over just the 6, because that's the only part that repeats. But if my math lab says to round, if MML, my math lab, says round to nearest, I don't know, 10th. Okay, if it says round to the nearest 10th, let's just do that real quick and get one last practice in with that. then you have to make sure you follow those directions super, super carefully. Now, this one is not that easy to round to the tenths, actually. This is kind of tricky. Let's go back up to here where we wrote out the number with all of our decimals. If you're rounding to the nearest tenths, the tenths place is right there. The 9 is in the tenths place. So that means you want to look directly to the right of it, and you see that that number is a 5 or higher. So that means this 9 technically would go up 1. That would turn into a 10, but you can't really put a 10 there. So that turns into a 0, and then you carry the 1 over here. Remember that? So your final answer is actually 6 if you were rounding to the nearest tenth. Oops, I'm off the page. Let's go that way. If MML says to round to the nearest tenth, then your answer is just 6. You would have to round to 6. If it doesn't say anything about rounding, then go ahead and just write your answer like this. So again, read the directions carefully. I would hate for you guys to miss points on something like that. All right, guys, that concludes lesson 13. This was another kind of lengthy lesson. You guys did great bearing with me. As always, if you have any questions at all, please shoot me an email. I appreciate all the emails so far that have been coming my way, and I just hope that you guys continue to do that. It's really our best way to communicate right now. So do not hesitate to email as much as you want or need, and please stay healthy as much as you can. I hope that all of you guys are still doing really well, and I hope none of you are negatively affected by this in any major way. So, all right, guys, stay in touch, and good luck with the lesson 13 and quiz 6 on my math lab. I'll see you soon. Bye-bye.